In 8.7, our goal is to use L'Hopital's rule to find limits with indeterminate forms. An indeterminate form of a limit is an expression of the form 0 over 0 or infinity over infinity. Actually, other indeterminate forms could look like 0 times infinity, or 1 to the infinity, or infinity to the 0, or 0 to the 0, or infinity minus infinity. There's a lot of different forms that when we use direct substitution to try to find the limit, it yields something that does not give us a value. So from these forms, we cannot determine the limit or even whether the limit exists. Now, usually we're going to come up with 0 over 0 or infinity over infinity. One of these other forms we might see, but then we can translate it into this. So if we see 0 over 0 or infinity over infinity, we can use L'Hopital's rule. L'Hopital's rule tells us that if f and g are differentiable functions, we have a quotient here that will yield 0 over 0 or infinity over infinity, and the derivative of the denominator is not 0, then it's the same as or equal to the limit of the derivative of the numerator divided by the derivative of the denominator. Notice that we're not using the quotient rule, but merely we're taking the derivative of the numerator and the derivative of the denominator. This is L'Hopital's rule. Remember, we can only use it if we get this indeterminate form. L'Hopital's rule, however, can be used multiple times for the same expression if it's necessary. Let's look at a few examples. Use L'Hopital's rule to find the limit of each expression. Make sure that direct substitution gives an indeterminate form first. We always use direct substitution. So I'm going to try direct substitution. And here's what I see. 2 squared minus 4 over 2 minus 2 equals 0 over 0. That's an indeterminate form. Now we know that we have the option of factoring. However, because we have this new method, let's try the new method. So I'm going to use L'Hopital's rule, which means I'm going to write the limit as x approaches 2, and I'm going to take the derivative of the numerator, which is 2x, and the derivative of the denominator, which is 1. Now I'm going to try direct substitution again. So using direct substitution, I plug in the 2 times 2 over 1, and that's 4. No longer an indeterminate form. Now I have the limit. So again, the idea behind this is now we have other strategies when we see an indeterminate form. Let's try this one. Maybe you try it on your own, pause the video and come back and check how you did. So let's see what we get. First, trying direct substitution. I do 3 cosine of 0 minus 3 over 3, 0 squared, because I'm plugging in 0. Cosine of 0 is 1, and therefore I get 0 over 0, another indeterminate form. So I'm going to use L'Hopital's rule. Limit as x goes to 0, derivative of the numerator, 3 negative sine of x over 2x. Use direct substitution now, plug in 0, 3 times negative sine of 0 over 2 times 0, and I get 0 over 0 again. Use L'Hopital's rule another time. Limit as x goes to 0. Now the derivative of this guy is 3 times negative cosine of x divided by 2. Derivative of 2x is 2. Plug in the 0, 3 times negative cosine of 0 over 2. Cosine of 0 is 1, so that gives me negative 3 over 2. And now I have a limit. How about the third one? Now, I'm not claiming that L'Hopital's rule is the way to always go. It's just another tool in our toolbox. For example, I see x approaching infinity. I'm going to use, if I have a polynomial over a polynomial, my degree shortcuts. I can tell just by looking at this that because the degrees are equal, I know my answer is going to be 3 over 5. However, because we're trying a new tool, let's see how that tool can be used here. Infinity plugged into x yields infinity over infinity. Now I'm not really getting a number, but I think a really large number squared gives me really large number over really large number, infinity over infinity. That's kind of the idea. So now I'm going to use L'Hopital's rule. L'Hopital's rule says do the derivative of the numerator. That will be 6x, and then the derivative of the denominator, 5x minus 9. However, plugging in infinity again yields the same indeterminate form. So let's just keep trying it until it works, or until we don't get an indeterminate form anymore, which means it works. So 6x makes 6, derivative of 5x minus 9 makes 5. And I pause and I think to myself, wait a minute, the answer was supposed to be 3 over 5, not 6 over 5. So what did I do wrong? Let's go back a step and check our derivatives. 3x squared, the derivative is 6x. 5x squared, the derivative is, oh, there it is. The derivative is 10x. Let's fix that. This derivative right here. So 10x minus 9, and then the derivative of 10x is 10. I can take that limit just by simplifying 6 over 10 to get 3 over 5. Now, obviously, L'Hopital's rule is not the way to go in one where we can just observe and see the limit. The idea is, if we get an indeterminate form, we just have a new tool.